Hello everyone, this is BSc TY class, complex analysis. So today we are going to discuss what is meant by the modulus of the complex number. So write down modeling or modulus of a complex number or absolute value of the complex number or distance of the point Z from origin. So these are some names for the modulus of a complex number. So modulus of a complex number is absolute value of the complex number is distance of a point Z from origin. If Z is a given point x plus I, it is a given point. So every complex number on the directed line can be represented like this. So this is imaginary axis, this is the real axis. So the point xy is equal to x plus I, and this is called as z plane or complex plane. So this is imaginary axis, this is real axis. So every point of a complex number can be represented on the directed line. The directed line means what? The line which has negative as well as positive part is called as directed line. Now, the number 2 plus I can be written as 2 plus I, which is equal to 2 comma 1. So this point can be represented on the directed line x. So x coordinate is 2, y coordinate is 1. So this one 2 plus I is equal to 2 comma 1. So every point from complex numbers can be represented on the directed line. Now this point xy, this is y, imaginary axis, this is real axis, and the point this x comma y is equal to x plus I1. This is real part of the complex number and this is imaginary part of the complex number. Then the distance between the origin and the point xy is called as modulus of a complex number. We know that if we have given 2 points, then the distance between 2 points is, if we have given 2 points x2 y2, then we know that the distance between these 2 points is x1 minus x2 whole square plus y1 minus y2 whole square. So this is the distance. Now find the distance x comma y and the origin. Then it becomes mod z is equal to x minus 0 whole square plus y minus 0 whole square. It is nothing but x square plus y square. So this is the modulus of any complex number. For example, find the mod of z1 is equal to 1 plus I, z2 is equal to 2 plus I, z3 is equal to minus 1 minus 3I. Then mod of z1 is equal to square of the real part 1 square plus square of the imaginary part 1 square is equal to n square root 2. Now find the modulus of this point. Modulus of z2 is equal to n square root. Square of 2 is 4 and square of n is plus 1. So it is equal to n square root 5. Now mod of z3 is equal to square of minus 1. This is 1 and square of minus 3 is plus 9. It is equal to 8. Now we can find absolute value of any complex number. So keep in mind this, every complex number can be represented on a directed line. That plane is called as Z plane. Now, this is about the modulus of a complex number. Write down the important note. Note 1. Z1 is less than Z2. Z1 is greater than Z2. Where Z1 and Z2 are complex numbers. Complex numbers is meaningless because we know that complex numbers is not ordered field, because complex number system is not ordered structure. Now keep in mind that Z1 is less than Z2, Z1 is greater than Z2. It does not happen in the set of complex numbers. We cannot say that 1 plus I is greater than 1 minus I, 1 plus I is less than 1 minus I. We cannot say like that because the set of complex numbers is not ordered field. It is meaningless. In the set of complex numbers that we cannot say Z1 is less than Z2 or Z1 is greater than Z2. And we know that Z1 is equal to Z2 if and only if their imaginary parts, X1 is equal to their real parts and imaginary parts are equal. So keep in mind this. But we can say that mod Z1 is less than absolute value of Z2 or mod Z2 absolute value of Z1 is greater than absolute value of Z2 because these two are real numbers. So modulus of a complex number must be a real number. So this is meaningless because we know that set of real numbers is an ordered field and it is ordered structure. Hence this is meaningful in the set of complex numbers. But this is a meaningless in the set of complex numbers. Now note, distance between two complex numbers. Distance between two complex numbers. If Z1 and Z2 are the given complex numbers, belongs to C, then distance between Z1 and Z2 is nothing but mod Z1 minus mod Z2. For example, if Z1 is equal to 1 plus I, Z2 is equal to minus 2 plus 3I, then find the distance between these 2 points, then mod Z1 minus mod Z2 is equal to mod of 1 minus minus plus 2, 3, and imaginary parts 1 minus 3 minus 2I. So mod of this absolute value of this number is 9 plus 4 is equal to root 13. Hence the distance between these two complex numbers is this. So we can find, or we can consider another example, second example. If Z1 is equal to 2 and Z2 is equal to 3 plus I, then mod distance between these 2 points is equal to, so 2 minus 3 minus 1 and 0 minus I minus I. So mod of this is 1 square plus 1 square is equal to in square root 2. Therefore the distance between these 2 points is square root 2. Now consider z plane. This is imaginary axis. This is real axis. This is our z plane. Now let this is our point z1, x1, y1. This is our point z2, which is x2, y2. Then this is z1 plus z2. This point is, keep in mind this, if z1 is this, z2 is this, then the addition z1 plus z2 is this point. Now this may be a minus z1, that is x comma minus 1. So this point is a minus z1, and so this point is a minus z1 because x is as it is, only the sign of the coordinate y changes. So this, keep in mind, if z1 is this, z2 is this, then there is some z1 plus z2 is this. Example, find the distance between the following pair of points. Following pair of points. So first 0, 0, comma minus 2 plus I, that is origin and minus 2 plus I. Second 0, 0, comma minus 3 plus I, that is origin and this point. Third 1 plus I, comma 1 minus I. 4 6 plus I minus 6 plus I. So we have to find the distance between these four pairs of points. Now first, z1 is equal to 0, 0, z2 is equal to minus 2 plus I. So these two are given points. So mod z1 minus z2 is equal to 0 minus 2, 2, and 0 minus I, minus I. So the mod of 2 minus I is equal to, in square root, 4 plus 1 is equal to the square root I. So it is nothing but the modulus of z2 is equal to the absolute value of z2. Now second, z1 is equal to origin and z2 is equal to minus 3 plus I. So mod z1 minus z2 is equal to absolute value of 3 minus I is equal to, in square root, 9 plus 1 is equal to root 10. It is equal to modulus of z2 because the distance between origin and the given point is called as absolute value. So it is third 1 plus I, 1 minus I. Z1 is equal to 1 plus I, z2 is equal to 1 minus I. Then mod z1 minus mod z2 is equal to 1 minus 1, 0, and I minus minus plus I, 2I is equal to, in square root 4, it is equal to 2. Therefore the distance between these 2 points is 2. Now 4, z1 is equal to 6 plus I, z1 is equal to 6 plus I, z2 is equal to minus 6 plus I. Mod z1 minus mod z2 is equal to 6 plus 6, 12, minus I 0 times I is equal to n square root 144 is equal to 12. So distance between those two points is 12. आजचं लेक्चर इथंच थांबूया. उद्या आपण काही एक्झाम्पल सॉल्व करूया आणि काही कॉम्प्लेक्स नंबरच्या प्रॉपर्टीज चेक करूया. थँक्यू.